There are three identities that are generally regarded as some of the basic identities, but they don't really come out of the triangle assignment and discussion that we just had. I want to walk you through them here. They're called Pythagorean identities because they really are based on the Pythagorean theorem. So let's put our triangle in here. Let's put a right triangle. Angles A, B, and C. So I have side lengths little a across from A, little b across from angle B, and little c across from angle C. Okay, so notice that the sine of, let's try that again. The sine of angle A is A over C, opposite over hypotenuse, and the cosine of angle A is B over C. No surprises here, adjacent over hypotenuse. What I'm going to do though is I'm going to look at, take the sine of A and square it, and then add to that the cosine of angle A and square it. So here we go. The sine of angle A is A over C, and I want that squared. And the cosine of angle A is B over C, and I want that squared. Okay, so this is A squared over C squared plus B squared over C squared, as I square both of those fractions. Notice that I have a common denominator, so it's easy enough to add those two fractions. I just put that common denominator there. I've got an A squared plus B squared on the top. And you might think I'm done here, but there is a relationship in this triangle between A, B, and C. Because it's a right triangle, I happen to know that A squared plus B squared is equal to C squared. So this numerator here is the same as C squared. So this fraction becomes C squared over C squared, which equals 1. Notice it didn't matter that I used A. I could have used B. It's just that the role of sine and cosine would swap, because where this B over C is the cosine of A, B over C would have been the sine of angle B, and likewise the A over C would have been the cosine of angle B. So if I had put a B in here and here, then I would have added the same two fractions together, but just in the other order. I still would have ended up with 1. It turns out that for any angle, take the sine and square it, take the cosine and square it, add them up, you will always get 1. I want to quickly note the notation here. We generally don't write it like this. We write it like this: sine squared A plus cosine squared A equals 1. Right. This notation is a video coming up that talks about this notation, but when we write that sine squared, we mean figure out what the sine of the angle is. Take the output of the function and then square it. Likewise, cosine squared A. Figure out what the cosine of A is first and then square it. You're not squaring the A, you're not squaring the angle, you're squaring the output of the trig function. Okay. Anyway, there's one of the Pythagorean identities. I mean, the proof really relied on the Pythagorean theorem right here. It's called a Pythagorean identity. Right. There are two others that we will get to in a later video, but there's the first one, and that's probably the one we use most often. So sine squared A plus cosine squared A equals 1.